I'm Katrina Rokosz. I'm a PhD candidate in Yang Chen's lab at Stony Brook University, and I'll be talking about some fish community dynamics in the Hudson River Estuary. So just an overview of how this is going to go. Just some background, my objectives, getting into the methods, some preliminary results, and then I'll recap it all, conclusions, major takeaways, and then kind of look into the future of those next steps. So just to orient you, the Hudson River Estuary is shown in this figure here. It extends 152 miles from the federal dam in Troy down to New York Harbor. It's a tidal estuary, home to over 200 fish species. It's facing a lot of changes with climate change and anthropogenic activities. But this figure is an oversimplification of the Hudson. There's a lot more connectivity of the Hudson, and it's missing some of those bigger connections. So this is still an oversimplification, but it's just zooming out a little bit and kind of showing giving the Hudson River a little bit more context. So it's connected to the Great Lakes through Erie Canal and onward to the Mississippi River. It's connected to the Atlantic Ocean, and it's home to over 200 fish species. These species are coming from a couple different places. You have the native fish to the Hudson River. Then you also have species that have been introduced, such as channel catfish, black basses. You have fish coming into the Hudson from canals, coming from the Great Lakes, and coming as far as the Mississippi, entering the Hudson, expanding their range, coming from the north. But then you also have these marine species coming in from the south. Warm adapted species are expanding their range. You get marine strays carried in by the Gulf Stream. So the Hudson River is at this intersection of freshwater fish expanding their ranges coming in from the north. And then you also have marine fish expanding their ranges and coming in from the south. And so these range expansions put the Hudson River in this unique location that is really driving questions of what's going on with the community, how's it changing. And so this is getting me to my objectives. My overarching objective is to describe and quantify the fish community dynamics of functional groups within the Hudson River Estuary. And then more specifically, diving into the impact of non-native species on the native species of the Hudson, assessing changes in marine species in the community, and then also identifying change points in community indices in the Hudson River Estuary. So for this work, for some of my indices, I divided the Hudson into 3 sections based on salinity, because salinity is a major driver of the fish community throughout the Hudson. So in the north, I have the more freshwater, or exclusively freshwater stretch of the estuary, and then you have the transitional section in the middle where the salt edge fluctuates, and then you have a more marine section in the south. And just to note for the survey that I'm using, the battery was not sampled for the first until 1988. So unfortunately, we're missing the first 11 miles of data for the first decade and a half. And this is where this section of the estuary is where you have a lot of marine fish coming in. So just keep that in mind. Getting into the data, I'm using data from the Long River Survey. This is part of the Hudson River Biological Monitoring Program. It's an ichthyoplankton trawl survey that started in 1974 and ran to 2017. It uses epibenthic sled and tugger trawl, and I wanted to use both gears because they sample different locations in the water column. The tugger trawl is the surface and midwater, with the epibenthic sled getting the bottom. I'm focusing on summer months right now, June through August, and the reason why I'm sticking with summer months for now is because the protocol for the survey was pretty consistent during this period. Spring and fall have some protocol changes that will impact diversity calculation or community calculations, and so just for consistency, right now, summer months. And then there's 2 major classes, eggs and post-yolk sac larvae are what I'm focusing on. And then for some of the indices, it's not on here, but breaking the estuary up into 3 sections like I previously mentioned. So I grouped the species or the taxon in my survey into different functional groups, and then classified within each group. For this survey, the whole Hudson River program that we have has 237 taxa. My survey that I'm using has 151 taxa. Within these taxa, there's 130 that were identified to species level, 21 were identified to higher taxonomic level. This is just, while they were out there, it's pretty hard to tell some species apart, especially early life stages. So like blueback and herring, and alewife, or if they weren't able to make a confident ID, they were just grouped as like Moroni unidentified or loops unidentified. And so that's what those higher taxonomic levels are. And so I have 4 different functional groups that I identified those 151 species or taxon. I grouped those in within each of those 4 groups. So for native status, it was either native or non-native. Zoogeography, freshwater, estuarine, marine, and diadromous. Thermal regime was cold adapted, warm adapted, subtropical, tropical, or aerothermal, and then feeding strategy, piscivore, plantivore, and benthivorous. And for all species taxon were classified, and then for those unidentified taxon, I made the assumption that they represented species that had only previously been caught in the survey. And so if there were common traits across those species, then I was able to also classify those higher taxonomic levels. Otherwise, I just left it as unidentified. For certain analyses, I didn't want to just completely remove that group from the community. And just a shout out to all the textbooks that were really helpful in these classifications. So for the preliminary analysis, what I'm looking at is relative abundance, and this is where I use the river, divided into 3 sections. And I use it for all taxa, so that's where that unidentified, unknown, potentially grouping shows up. And then I also am looking at richness, but only on the species level, and that's across the whole river. And then diversity, again, species level for the whole river. And then I'm including pellet change point analysis on the richness and diversity indices to try to see if there's, what years there might be changes in, statistically significant changes in our indices. So getting into some of these preliminary results, here we have, for the native status, egg relative abundance and post-yolk sac larvae relative abundance. Native is in blue and non-native is in purple, and then the columns are the gears, Tucker trawl and epibenthic sled, and then upper estuary, middle estuary, and lower estuary. And looking at this, the purple, the non-native in that, for eggs in that upper estuary paneling in the last couple decades has really increased. And I was pretty surprised by this. You don't really see it throughout the river. You don't really see it in the post-yolk sac larvae. They disappear. And what this is actually is freshwater drum. They invaded the lake in the mid-90s and then became more established in the early 2000s. And they're summer spawners. Again, this is just the summer time period. They're summer spawners. And so in the recent decades, they have really just taken over the egg community in the freshwater region of the Hudson. But they're not really there for the post-yolk sac larvae, and I did a preliminary just test that I'm not showing here, but looking at the yolk sac larvae community, and it's kind of this gradient, they're slowly falling out in the relative abundance in the community. And what's dominating the post-yolk sac larvae community is actually these unidentified kloops. And then there's also some striped bass and white perch eggs up in that region too. But so there seems to be some sort of environmental or habitat conditions that's not really allowing freshwater drum to grow to that post-yolk sac larvae stage, at least compared to the rest of the egg community. I don't have a reason why. I'm just starting this. But interesting to note. Getting into the richness trends, we have eggs on the top panel, post-yolk sac larvae on the bottom. The vertical lines represent change points, like dashed vertical lines. And the 1987 is noted because that's the last year where the battery was not sampled. So you can see that with the addition of the battery, richness dramatically increased for native species and native species eggs. And then post-yolk sac larvae, there was an increase, then it's stabilized a bit. And then looking at diversity, you have native eggs increasing quite a bit. And then in 2012, there was another change point indicated, and this is also a consistent change point that I found. And there was a marine heat wave that year. It was extremely hot. The Hudson River also had an extremely hot year. And so it changed the community then, so it's also reflected in our change point analysis. And then post-yolk sac larvae, it's after initial increase in diversity, it's been pretty consistent for the native group. Looking at zoogeography, you have in the upper estuary, you see the freshwater increase. That's again the drum for the eggs that aren't there for the post-yolk sac larvae. And then you have increases in marine species for the post-yolk sac larvae. Just to keep going with richness, after the addition of the battery, again, dramatic increase in egg richness, whereas everything else has remained fairly consistent, a slight increase in freshwater, and then similar trends for post-yolk sac larvae, except diagenous fishes have been decreasing. And then just the diversity indices again, increases in marine diversity for eggs, decrease in marine diversity for post-yolk sac larvae, diagenous fishes dropping off. For thermal regime, the warm adapted species are overwhelmingly dominating the Hudson River estuary. And then getting into richness, you see increases in warm adapted species. Slight increase in cold adapted species eggs, but a decrease in their post-yolk sac larvae. And then diversity increasing, warm adapted eggs, and for post-yolk sac larvae relatively stable. We do see subtropical and tropical species, those are in the yellow, they only show up for post-yolk sac larvae, just to note. And then lastly, we have feeding strategy. For the eggs, you have in the brown up top the upper estuary increasing in the Benthamore community. Those are those freshwater drum eggs. But you also have that in the post-yolk sac larvae community in the lower estuary. That's the marine section. And what that is representing is like a little bit of weakfish and then unidentified gobies, which I'm not really sure what's going on there either, and I need to look into that more. But that would be like seaboard goby, naked goby. And then getting into richness, the Benthamore community, or it's just the egg community has been increasing in richness across the board, and then initial increases in post-yolk sac larvae before it's stabilized. And then just diversity, generally post-yolk sac larvae diversity has been declining. So that was a lot. There was a lot of figures, a lot of data. So just to recap some takeaways of the bigger trends. The upper estuary egg community is dominated by freshwater drum in recent years, whereas the post-yolk sac larvae community is dominated by unidentified plupes, white perch, striped bass. So there's indicating some sort of potential habitat in environmental conditions that inhibit freshwater egg development to older life stages. Species richness for marine species has been increasing for both life stages. Other zoogeography groups have remained fairly consistent. Post-yolk sac larvae, diagenous fishes have unfortunately been decreasing though. And warm adapted species are doing very well. But richness has been declining for cold adapted post-yolk sac larvae. Looking at the change point analysis, change points were found for most functional groups, but I need to dive into this a little bit more. There were also change points in the 90s that there wasn't really a consistent year for the change points. But what I think this might be showing is zebra mussels came into the Hudson in 1991, and then they had a pretty big impact on the fish community in the Hudson River. And so these change points for these different functional groups might just be reflecting how the zebra mussels were impacting these different groups at different time scales. And there's a lag for certain groups compared to others. 1987 and 2012 were consistently found to be change points. 87 is indicating the protocol change and how that impacts our community indices, whereas 2012 is showing how environmental conditions are having an impact on our community indices. So the major takeaways is the Hudson River fish community has been changing across all functional groups. the connection between the Atlantic Ocean and the Great Lakes impacts the Hudson River fish community, but sampling protocol is also having an impact on our calculations. So just has to be aware of what's actually environmental and biological versus changes in sampling protocol. So looking at the next steps, I'm hoping to expand this to spring and fall. We do have some pretty major protocol changes during these seasons that would likely impact some of our calculations, so I'll have to figure a workaround for some of this. I want to expand this to additional life stages. This would require incorporating an additional survey, the fall juvenile survey, which targets young of year and Yoi, but just increasing the life stages to see what's going on. And then additional change point analysis, as I had previously recommended, kind of diving into some of these patterns that I'm noticing and different methods just to validate some of the years. And with that, I'd just like to acknowledge the people that have helped with this research, specifically Claire Bird, Sarah Yang, and our lab, my dissertation community, including Young, Bob Serrato, Mike Frisk, Kevin Friedland, and Greg Kenny, Hudson River Foundation, Stony Brook, IAX, NGG, who gifted the HRBMP to Stony Brook, and the New York State TBC. Thank you.